Alright, today we're going to be looking at how to solve a system of equations by graphing them. So solving a system of equations by graphing, essentially we're going to have two lines that we're going to graph, and we want to know which ordered pair satisfies both equations, which is going to be the intersection of the two lines. So all we need to do this is graph the two lines, which means that I want them both to be in slope-intercept form, so I can graph them, and then I want to know where they cross. So the first one is in slope-intercept form, so I can go ahead and keep the first one as it is and graph it when the time comes. The second one, however, is not in slope-intercept form, so I'm going to have to get the second one into slope-intercept form. So that means I need the y by itself, so I'm going to subtract the x, which is going to give me negative y equals negative x, and I do need to get rid of this negative sign. So I'm going to, remember that means that there's a negative 1 out here, so I'm going to divide by negative 1 on both sides. So my second equation becomes y is equal to x. So first equation, y is equal to negative x plus 6. Second equation, y is equal to x. So I'm going to graph each of these. Let me start with the second one. The slope of the second one is 1 over 1. The y-intercept of the second equation is 0, 0. So that one I'm going to graph in blue. So 0, 0 is the y-intercept, and the slope is 1 over 1. So up 1 over 1, up 1 over 1. I could also go down 1 over 1, down 1 over 1. But you'll notice I'm going to be graphing a lot of points for this type of problem. And the reason for that is because it's going to make it easier for me to tell where they intersect if I have multiple points to work with. So here's the second line. Alright, pretty much every ordered pair has the same xy coordinate. 1, 1, 2, 2, 3, 3, 4, 4. I'm going to now graph the first line. And I'm going to do it over here where I've got room. So the slope of the first line is negative 1 over 1. And the y-intercept is 0, 6. So I'm going to graph, and actually let me rewrite that in a different color so I can graph it in a different color so they stay together. I'll do that in red. So like I was saying, the slope of the first one, this is this one, is negative 1 over 1. The y-intercept is 0, 6. So I'm going to graph the y-intercept 0, 6. I'm going to use the slope to get more points. Now, even the first line had a positive slope, so it's pointing up. The second line has a negative slope, so it should be going down this way. So I'm going to go down 1 and over 1. Now the thing is, I'm looking for where these lines cross each other. So I'm going to keep going until I hit the blue line. Down 1 and over 1. Down 1 and over 1. And we'll see that we're going to get a point here where they intersect. Let me draw my line first. Alright, so we have a point of intersection here. The point of intersection is 3, 3. And that is our solution to the system. 3, 3 will give you a true statement when you plug it into the first equation and the second equation. It's a solution to both of them, which means it's the only solution to the system. It's the only solution that matches, that goes with both equations. So 3, 3 would be our solution for this first example. Let's take a look at another one. So the first one, y equals negative 3. The second one, 3x minus y equals 6. The first one is already graphable. We don't need to do anything to graph that one. But the second one 3x minus y equals 6, we do need to solve this one for y before we can graph it. So let me solve it for y. Subtract 3x. And I get negative y equals negative 3x plus 6. And now I do want it to be positive y, so I do need to divide by negative 1. Divide this by negative 1, divide this by negative 1. So my second equation becomes y is equal to 3x minus 6. It has a slope of 3 over 1, and it has a y-intercept of 0, negative 6. So let's graph this one first, since we already have the information. This is the second equation. So 0, negative 6 is right here. And the slope is 3 over 1, and it's positive, so it should be pointing up. So up 3 over 1, up 3 over 1, up 3 over 1. Okay, I'm going to graph as many points as I can so that hopefully I will be able to find the intersection. Okay, so there's the second line. The first line is y equals negative 3. And that's going to be one of those special cases we saw before where every point has a y-coordinate of negative 3. So 1, negative 3, 0, negative 3, 2, negative 1, negative 3, negative 2, negative 3. It's going to be a horizontal line that goes through negative 3 on the y-axis. And you can probably tell where these two are about to intersect. These two are crossing right here at the point 1, negative 3. So 1, negative 3 would be our solution to this entire system. So where these two lines cross, 1, negative 3. Okay? So that's how you solve a system by graphing the lines.